Good morning, everyone. I am Nitish Garg, pursuing my bachelor's in electronics and computer engineering from Thapar Institute of Engineering and Technology.
Good morning, everyone. My name is Himank Jindal. I am currently pursuing a bachelor's in electronics and computers branch.
Good morning, everyone. My name is Mayukh. I'm pursuing my bachelor's in electronics and computers.
Good morning. I am Shruti Singh, pursuing my Bachelor's of Engineering in Electronics and Communication.
Good morning. I am Riya Bajaj, pursuing my Bachelor's in Engineering in Electronics and Computers. The topic of our capstone project is stock price prediction using sentimental analysis. Prediction and analysis of the stock market are some of the most difficult tasks to execute. There are numerous reasons for this, including market volatility and a variety of other dependent and independent variables that influence the market value of a particular stock. Because of these factors, it is extremely difficult for any stock market expert to predict the market's rise and fall with great accuracy, and thus it becomes challenging for the investor to invest the money to make profits. So, the major goal here is to develop a model for estimating stock market future trends with a low error ratio and improve prediction accuracy. We have used data mining to extract information from huge and complicated data sets, resulting in superior stock market trend predictions. To forecast future stock market behavior, we have combined financial news sentiment analysis with attributes taken from historical stock prices. We implemented both the sentiment analysis and historical data models and together used the results to create an effective market prediction model. So, initially, we started with the basic solution for predicting stock prices from previous stock prices, and the model we used for training the purpose is the recurrent neural network model. This method seems to perform well at first glance. Val loss was only 0.0194 of the last iteration in the single step forecast. It performed well. However, when predicting multiple steps into the future, the model performed very poorly.
So, in the next method, instead of predicting the next price using the previous price, we tried to predict returns in the stock price. That is, by how much percent will the price go up or down. And this is the graph we received to forecast target versus prediction. The model performed poorly as inferred from the graphs. Nextly, in this method, instead of predicting price, we tried to predict whether the price will go up or down. This simplifies the problem to binary classification. This is a much easier task than compared to predicting the actual price. Using this method, train accuracy was 93%. However, the test accuracy was only 50%, which is not better than random guessing. Method 3 was a much easier task than that method 1 and method 2. Since the model fails to perform well even on this task, it would not have worked in predicting actual price even with hyperparameter turning. Predicting prices from previous prices may seem possible at first glance. However, there is a fundamental flaw in this approach. This approach doesn't take into account real world events. Stock prices do not depend only on the previous prices, it can be one of the factors. The future is not completely deterministic from historical events. A more realistic scenario would be that the prices depends on the emotions and investors, how the media portrays the company, etc. Now, our next target is to use this real world information about the company and economy to try to predict the price. For this, we imported news headlines using an API and converted that data to a JSON file. Other data we used in previous data of the stock market dynamic of Google containing features like open, close, high, low, etc. We sorted and processed all the data, extracted words from the headlines, and used sentimental analysis to predict whether the data is positive, negative, or neutral to predict future trends of that particular stock. We trained our model using LSTM in this model. LSTM stands for Long Short-Term Memory Network. Used in the field of deep learning, it is a variety of recurrent neural networks, RNNs, that are capable of learning long-term dependencies, especially in sequence prediction problems. LSTM network combat the RNN's vanishing gradient or long-term dependency issues. Then after testing the dataset, we calculated the accuracy, which turned out to be 64.9%, which is better than the previous models. Thank you.